We are continuing to work through the Math 136 test number 1 review homework problems. We are ready now for problem 19. This is another problem where we're given a graph or the graph of a function and we're asked various questions. So I think I'll just try and work it out. I'll try and zoom in a little bit. You should have this problem also available to you. So here's a graph of the function. And then we have some questions. So we'll just start working through these and discuss each of these questions and go from there. Looks like they have summarized the questions here, but they actually asked them down here. So I'm going to skip this part and just go right to here. So the first question is the graph that of a function? Okay, the way we check to see if this graph is a function, it's very easy when you have a graph. We have this thing called the vertical line test. All you do is you look at your graph and you imagine, either in your mind or you can even do it by writing, but I'll just sort of imagine in my mind. You start drawing vertical lines and you look at all the vertical lines that will pass, that you could fit on your graph. If you can find a vertical line that crosses the graph in two different places, then it is not a function. If every vertical line that you can draw only crosses the graph once, then you have a function. So hopefully you can see, as I'm moving my pen, if I were to be drawing vertical lines, every one of these vertical lines only crosses the graph once. Let me give you an example of a graph that would not be a function. Maybe we have some kind of a sideways parabola. So here, hopefully you can see, if I drew a vertical line just like this, the vertical line would cross the graph in two different places, which means this would not be a function. However, when we use a vertical line test for our graph, we see it is a function. So we'd say yes. Then the next question is, if the graph is that of a function, what are the domain and range of the function? Select the correct choice below and fill in any answer boxes. So they ask for the domain and the range, or they give you an option that's not a function. Of course, we know it is a function. I like this question better than the last one because it does ask for the answer in interval notation. So on the last problem, we discussed how to find the domain and range when you have a graph. If you recall, the domain are all the possible values of x. So if you have a graph like this where it's continuous, in other words, there's no breaks as you move from left to right, then what you do is you go look for the smallest value of x, and then you go look for the largest value of x. You notice we have arrows here, which means that these lines go on forever. So you say, what's the smallest value of x? How far does this graph go to the left? Well, we could write it here. It actually goes to minus infinity, because this goes on forever. And how far does this graph go to the right? Once again, because of this arrow, it's infinity. So the domain, written as an interval, starts at negative infinity and goes to infinity. And those both have parentheses, because interval notation, you always put parentheses when you have infinity. Now the range are the possible values of y, so we look up and down. So we're going to first see how far down does this graph go. What's the smallest value of y for this graph? Now we look at it, once again, these lines are going down, and because of the arrows, they go on forever. So once again, it looks like the smallest value in the y direction is negative infinity. Now as we go up, you notice the graph here, once we get past this sort of horizontal line, there are no more points. So if I'm asking what's the largest value of y for this graph, it has to be right here. And when I look at these points, it's telling me that the value of y is 6. So I would say the range goes from minus infinity to 6. Now 6, I put a bracket because you notice the graph includes the value of 6. So the range goes from negative infinity to 6 and includes 6. Next question. What are the intercepts? Select the correct choice and fill in the answers. Now here, it's a little tricky because I think on the last question when they asked for x and y intercepts, they just wanted a number. Here, they asked for the ordered pair. So therefore, what are we doing? We have two kinds of intercepts, x-intercepts and y-intercepts. It looks like to me they sort of bunch them all together and just say, hey, give us all the intercepts, and when you give us the intercepts, write it as an ordered pair. In other words, an x and a y. So if you look, I believe we have 3 intercepts. There is an x-intercept, there's a y-intercept, and there's an x-intercept. So if you look at this graph, this first one, I believe if this is minus 12, 1, 2, 3, 4. It looks like every notch is minus 3. So it looks to me like that first one is minus 9. And of course the y is 0. Then this one looks like the y is 6 and the x is 0. So 0, 6. Then this one, 3, 6, 9, looks like the x is 9 and the y is 0. All right, and then the last one. Determine if the graph is symmetrical with respect to the y-axis, symmetrical with respect to the origin, symmetrical with respect to the x-axis, or if it's not symmetrical, or not even a function. Symmetrical means, what happens is, symmetrical means, sometimes I like to think of like a mirror image. Like if we say symmetrical around the y-axis, if I were to imagine this y-axis and I look on both sides of it, it's like if I folded this graph along the y-axis, would these things match up perfectly? And in this case, they would. You can imagine if I lifted this page up and moved them together, they're identical. Symmetrical with respect to the x-axis means if I were to fold the pages up like this, would they look like each other? No. Another way to think of this is like a mirror image. In other words, like this is over here is the real and this is like the mirror. Does this look just like this? Yes, it does. So it looks like to me like this is symmetrical with respect to the y-axis. And that's that problem. Not very difficult, hopefully. If I look at the next one, actually number 20 is another function of a graph with various questions. Here it looks like, almost looks like some kind of parabola. I want to make sure this is focused. All right. Once again, determine whether the graph is out of a function by using the vertical line test. If it is, use the graph to find. So it's just like the last problem. First question, is the graph that of a function? So if we do a vertical line test, is there any place that we would cross the graph twice? No, there's not, so that means yes, it is a function. Now we're asked for the domain and range in interval notation. Remember domain, smallest value of x, the largest value of x. You notice we have arrows on the end of this graph, and it continues to get wider and wider as it moves. So therefore, the domain is going to be negative infinity to infinity. Now the range is the values of y, and you start with what's the smallest or the lowest value of y, and what's the highest. Well, in this case, since it's this sort of like a parabola, there is a point here where the graph does not go any further down. So it looks like the lowest value of y for this graph is this point right here, which we also called the vertex. And it gives me that point. It says the point is negative 3, negative 1. Negative 1 is the value of y. So it looks like my range is going to start and include negative 1. So I put a bracket, negative 1. And then what's the highest point? What's the largest value of y for this graph? Well, since it goes on forever and it keeps going up, it's going to be infinity. Next question. If the graph is out of a function, what are its intercepts? Just like the last time, and they want it as ordered pairs. So where does this graph cross either the x-axis or the y-axis? Looks like there are two places where it crosses the x-axis, here and here, and then one place where it crosses the y-axis. So it looks like there are three intercepts. So if I look at this point here, looks like it's minus 4, 0. And this point here is minus 2, 0. Looks like there are two x-intercepts. And then we got this y-intercept. Looks like each tick mark is 2. So 6, 8. Looks like 0, 8. So those are the intercepts. And now we have this question about symmetrical with respect to x or y. Well, you can see my y-axis is right here, so it's not really a mirror image. Parabolas can be mirror images, but they have to be centered around like the y-axis. But this thing is shifted. So if I were to like fold this paper along the y-axis, it would not be the same image. And of course the x either. So in this case, we actually say D, it's not symmetrical with respect to anything. All right. Hopefully you're getting the hang of those. Not too difficult if there's one of those on the test. All right, let's do one more for this video and then. So this one is not a graph. However, it is a function, but now the function is in the form of an equation. So let's sort of see what we have here and then try and figure out what's going on. Answer the following questions about the following functions. There's a function, f of x equals 2x squared minus x minus 1. Now I could go through these questions here, but basically over here they repeat the questions. Let's just move over here and see what we have here. Choose the correct answer below. So they give me 4 choices. I got to figure out, and I think what's happened is just one answer is correct because it says choose the correct answer. It looks like I have to actually read question A, because here's the question and then here's the possible answers. So I guess question A is the point 2, 5 on the graph of f? And then it looks like I have 2 yes answers and 2 no answers. They must give different reasons. So let's talk about what we're even looking at. So we're looking at this point 2, 5, and we're seeing if it's in this function. I've told you before, this is the kind of problem where sometimes it's easier, it's clearer, if you replace f of x with y. So I could rewrite this equation as y equals 2x squared minus x minus 1. This makes it a little simpler, especially as we're talking about points, because we like to think about points as x and y. So I prefer to do this. Once again, the key is every time they ask you a question, you realize that f of x and y are synonymous. They really have the same meaning. So basically they're saying, if I plug in the 0.25 into this equation, does it work? Where I plug in 2 for x and 5 for y. So basically they're saying, would this be true? If I plug in 2 for x, and would it equal 5, which is y? Well, we have to see. So this is 4. 2 times 4 is 8. Minus 2 minus 1. It looks like it does check out. So yes, this ordered pair actually is a solution to this function, this equation. So the answer is yes, but there's two possibles. Yes, the first one says because substituting x equals 2 into the equation results in 5. That's true. But let's see what this one says. Yes, because substituting x equals 5 into the results in 2. So C has it backwards. C, they put 5 in for x and solve it equals 2. That's not correct. We actually need to put in 2 for x, see if it equals 5. So this is our answer. Part B, let's go to this question here. If x equals negative 2, what is f of x? And then what point is on the graph of f? So now we're saying, okay, let's plug in negative 2 for x and see what f of x equals. Or you could say see what y equals. So we would say f of x, plug in negative 2 for x, so 2 times negative 2 squared minus a negative 2 minus 1. Negative 2 squared is 4. 4 times 2 is 8. We subtract a negative. It's like adding. 8 plus 2 is 10. So it looks like when we plug in negative 2 for x, y, or f of x is 9. So I would put that here. I would say when x is negative 2, f of x equals 9. And then it says, use information in the previous set, list the points on the graph S where x is minus 2. So the point is, when x is minus 2, f of x or y is 9. So they want us to enter an ordered pair. Part C, if f of x equals negative 1, what is x? So we're sort of going backwards. They're now saying, okay, we're going to give you a value for f of x or value for y, which is negative 1, and they're saying, figure out what x equals. Now the interesting thing is, this looks like a quadratic equation. I need to solve it for x. The way we solve a quadratic equation is we set one side equal to 0. So I'm going to add 1 to both sides. Now this, when I add 1 and this negative 1 cancel out, so I'm left with this. So this is actually pretty easy to factor. That's how we're going to solve this. We're going to factor out the x, and you get 2x minus 1. So I'm going to have two solutions. The first solution is 0 from this x, and this x, I realize what value of x would cause this parenthesis to equal 0. If you wanted to, you could go over here and solve this equation. And when you do that, you realize that x is 1/2. So there are 2 points, 2 values of x that would give us a value of y, or f of x of -1. So first of all, when we set f of x to -1, there are actually two values for x. And now, the second part, they want then to write these as ordered pairs. So what we're saying is, when x is 0, f of x or y is -1, but also when x is 1/2, f of x is also -1. Actually, two different values of x will cause the function to equal -1. Now, what is the domain of f? Now, this is a little trickier. Actually, what I'm trying to think what would be the easiest thing. Sometimes when I have a graph of a function, the domain is really easy to see. So maybe I might try and just quickly graph this. There are other ways probably to do the domain, but let's just see what this looks like. And if you're ever in doubt, you can always just do an XY data table. That's going to be how we graph, right? So if we say if x is 0, y is -1, what if x is 1? If x is 1, we have 2 here. 2 minus 1 is 1. 1 minus 1 is 0. How about when x is -1? -1 squared is 1. 2 minus a -1 is 3. 3 minus 1 is 2. If I didn't mess up, let's maybe do 2 more points. How about when I plug in 2? 2 squared is 4 times 2 is 8. 8 minus 2 is 6. Minus 1 is 5. How about when I do -2? -2 squared is 4 is 8 minus a -2, which is 10. Now I'm going to sort of do a quick sketch of this graph and see what it looks like. 1, 2, 3, 4, 5, 6, 7. This is a very rough sketch. 0, -1. 1, 0. -1, 2. -1, 2. 2, 5. -2, 9. So it looks like it's a parabola. Now the key is, I don't know precisely what it looks like, but you know what? They're asking for the domain, and any kind of parabola like this keeps getting wider and wider, so all I really care about are the values of x. And the good thing is, I know the domain, or the smallest value of x, is going to be -infinity, and the largest value is going to be infinity. Now list part E, I guess up here, list the x-intercepts, if there are any. How do we find x-intercepts? When you have an equation, to find x-intercepts, here's what you do. You set y equal to 0 and solve for x. You set y equals 0 and solve for x. You take your equation. Here's my equation. I'm going to use the y version. And if I set y equal to 0, and now I solve this equation for x, those x's will be the x-intercepts. Now this is a quadratic equation. I wonder if it factors. The way we do factoring, the product is -2, the sum is -1, so it looks like my factors would be -2 and 1. So I rewrite this, 2x squared minus 2x plus x minus 1, and then you factor out. I'm doing this quickly because I assume you know how to factor. I'm not going to be able to teach factoring here. But when you get all done, looks like it's x minus 1 times 2x plus 1. That's all equal to 0. When you solve for x, you get 1 and negative 1/2. So it looks like there are 2 x-intercepts. And for the answer, they just want them listed as numbers. So I can put 1, negative 1/2. And then y-intercepts. Now for y-intercept, you do the opposite. You set x equal to 0 and solve for y. Now I'm almost out of room, but I can squeeze it in here. So here's my original equation. I'm going to set x equal to 0. And I can look here. If I set x equals 0, this is 0, this is 0. All I have left is y equals negative 1. So it looks like I have one y-intercept, negative 1. I think that's it. Now I have the answers, and just so I don't mislead everybody, I'm going to quickly check and see if I did this all correct, because I don't want to make a mistake and confuse everybody. And so far it's looking good, and actually it looks like everything is correct. All right, we'll stop here now and start another video soon.